Hello everyone. In continuation with respect to the compensated flow control valve, here in this case the pressure compensated flow control valve is operated by means of the two ports. The first port is nothing but the compensator spool. The second one is nothing but the what we can say the main spool. The main spool is controlled by means of a screw. The compensator is by means of a spring. The symbolic representation with respect to the pressure compensated flow control valve is also shown in the right side, where the flow is taking place from A to B, and a vertical line with an arrow, and a concave and as well as a convex shaped a arc will be arc which is controlled by means of another inclined arrow. This is a symbolic representation of the pressure compensated flow control valve. Now as we know that if the pressure starts increasing it, automatically the temperature is also starts increasing it. If the temperature starts increasing it, automatically the performance in the system starts decreasing it. The performance of the flow control valve is also affected by means of the temperature change, which changes the viscosity of the fluid. In turn, once if the viscosity of the fluid changes, automatically there will be a pressure drops will all pressure acting at the application will also changes. Therefore, often the flow control valves have a temperature compensation also. Even with respect, if the flow control valve or the pressure compensated flow control valve consists of a temperature control, means it is symbolically represented with a vertical line at the bottom, a something like a dark circle, that is indication of something like a temperature, which or indication of something like a thermometer. These type of valves are also having a major application in the circuit. The next part what we are discussing is with respect to the hydraulic circuits. The hydraulic circuits plays a major role in any hydraulic systems, or it may be a fluid power systems, or it may be in the case of the pneumatic power systems. These hydraulic circuits, either it may be a fluid or it may be a pneumatic. These basics is same as that of the electrical circuits. Even in the electric circuits also, there are so many components, like either it may be resistors, or it may be capacitors, or it may be motors in the case of the electrical. The same way, even here also, the hydraulic circuits consist of either it may be a DCV valves, or it may be a pressure control valves, or it pressure relief valves, or it may be a flow control valves. These are represented by means of a symbolic representation. This symbolic representation is also called as a hydraulic circuit, or it is also called as a ladder diagram, where how the fluid is flowing in the circuit, that it is represented. A hydraulic circuit is a group of components such as either it may be a pumps, actuators, control valves, and even the conductors arranged so that they will perform a useful task. There are three important consideration should be taken into consideration while designing a hydraulic circuit. Is the first thing is nothing but the safety of the operation, that it should matters in all the cases, either it may be in the case of electrical devices, or it may be in the case of the hydraulic devices. The first thing. The second thing is a performance and also desired function. See, as you know that the performance matters for the applications. In either it may be in the case of the electronic circuits, or it may be in the case of the hydraulic circuits. If the performance is not at all there, automatically the efficiency will start decreasing it, or the outcome of the circuit will fails, then automatically the efficiency will start decreasing it. The third part is nothing but the efficiency of operation. The efficiency of the operation means, if there is any leakages in the circuit, even that also it should be compensated. If it is not compensated, means automatically at the application end there will be a failure. These are the three major consideration we have to consider while designing a circuit. And also it is very important in a fluid power technician or a designer to have a working knowledge about the components and how it is operated and where it has to be inserted in the circuit. A hydraulic circuits are developed using a graphical symbol of all components. Before a hydraulic circuit can be understood, it is necessary to know the fluid power symbols. Once if you know the symbols, it is very easy to draw the circuits. If the symbols is not at all known, it is very difficult to draw the hydraulic circuits. For that reason, in further discussions, there are two sketches over there. One is with respect to a sketch with only the symbols, the another sketch or another diagram with a symbols. Along with the symbols, a namings will also be there. Maybe these things it will be at the beginning for the 1 or 2 3 circuits. Once if you are perfect with respect to the notations, or it may be the symbols of the components, like either it may be DCV valves, or it may be pressure relief valves, or it may be a flow control valves, then in further sessions, or it may be in the further circuits, the second part it won't be there. Next, going into the further in the further session, or going into the next part, the control of a single acting hydraulic cylinder. First we will go to the sketch, and then afterwards we will come back to the explanation part. See here, the schematic diagram shows the what we can say a circuit of the circuit, or a hydraulic circuit, or it's also called as a ladder diagram. Here it consists of totally 5 to 6 elements. These 5 to 6 elements are symbolically represented, and which are connected and by completing a circuit. This circuit is for a controlling of a single acting hydraulic cylinder. That too, especially the single acting cylinder is loaded by means of a spring loaded. As we know that the right side part is also same as that of the left side diagram, but in the right side part everything is symbolically represented, and even the symbolical representation along with the what we can say a notation, like either it may be C, P, E, T, F, R, and as well as a D. Along with that, a small explanation is given what type of the parts is. The C is representing it as a cylinder, P is representing it for the pump, E is for the electric motor, T is for the tank, F is for the filter, and R is for the relief valves, and D is for the DCV valves, which is nothing but a direction control valves. Even this direction control valves is also either it may be a solenoid control, or it may be manually control, or it may be spring operated. Depending upon the type of the operation, even that explanation will also be given. Okay, coming into the diagram, see for the explanation with respect to the circuit, I will start explaining it from the bottom to the top. As you know that in the bottom, which is represented something like a cup shape, which is nothing but a tank, over which a rhombus shape which has been represented, that is nothing but a filter. The filter is in turn connected to the pump. After the pump, again to the right side, that is nothing but a relief valve. The relief valve is a pressure relief valve, which is to be in the line between the what we can say a direction control valve and also the pump. After that, a direction control valve is there. This direction control valve is manually operated, and retraction is done by using the spring force. Then after that, the same thing is in turn connected to the cylinder. This cylinder, the movement of the cylinder, the forward path is done by using the pressure of the oil. The reverse is done by using the spring pressure only. This is a small explanation with respect to the what we can say the control of a single acting hydraulic cylinder. Now As the figure shows, the circuit consists of the filter. Before the filter, a tank will be there, and the pump, the pressure relief valve, and also direction control valve, and also the spring return single acting cylinder. In the operation with the cylinder is normally retracted position under the spring pressure. When the valve is operated manually, the pressure port open and the fluid starts flowing into the cylinder. Once if the fluid starts flowing into the cylinder, automatically the pressure is developed on the piston. Once if the pressure starts developing in the piston starts moving from the piston end to the rod end. In some what we can say in the circuit diagram, while explaining it, the piston end is also called as the blank end, but the other end is nothing but the rod end. As the piston starts moving in the forward direction, which is nothing but from the piston end to the rod end, the fluid starts filling in the cylinder. Okay, the retraction takes place by using the spring pressure only. At that time, what will happen? The fluid starts flowing in a reverse direction through the DCV valves, and the same thing it will be accumulated in the tank. This is an explanation with respect to a single acting hydraulic cylinder. The schematic diagram or the hydraulic circuit of a single acting hydraulic cylinder is also shown in this slide.